You are standing on the edge of the world, not the metaphorical kind, the literal kind. The ledge beneath your feet is less than a meter wide, and on every side of you nothing, just open sky. Just the cold, indifferent geometry of altitude. The wind here doesn't push you, it reaches inside you. It turns the space beneath your feet into a question you cannot answer. You have climbed nothing, you have taken no elevator, you simply rose. And now, from here, from 443 meters above sea level, you understand something that no human has ever understood from lived experience. The sky is not empty. The sky is yours. What are you? What could possibly belong here? You are not a bird. You are not a dinosaur. Not technically. You are something older in concept and more extreme in execution, a pterosaur, a lineage that conquered the air before the first feather ever existed. But you are not just any pterosaur. You are Quetzalcoatlus northropi, and you are the largest flying animal this planet has ever produced. Your wingspan is between 10 and 11 meters, not estimated, measured. From fossil fragments unearthed in the Big Bend region of Texas in 1971, paleontologists have reconstructed a creature whose wingtip to wingtip distance rivals a small aircraft. When you stand, and you do stand, on all fours, using your folded wings as forelimbs, you rise to the height of a giraffe, nearly 6 meters from foot to the crest of your skull. Your weight is the subject of genuine scientific debate. Estimates range from 70 kilograms at the absolute minimum to 250 kilograms at the upper bound. The number matters because flight, at this scale, is not just improbable. It is a mechanical argument against physics. And yet, you fly. The mechanism is not what you might expect. You do not flap constantly. You cannot afford to. At your size, sustained flapping flight would consume energy at a catastrophic rate. Instead, you soar. Thermals. Rising columns of warm air generated by heat differential between urban surfaces and the surrounding atmosphere. A city like New York produces them constantly. Every dark rooftop, every sun-baked asphalt avenue, every ventilation stack, they are all invisible elevators. And you know how to read them. You lock your enormous wings into a rigid glide angle. You find the thermal. You circle upward inside it like a slow, silent spiral. And when you reach altitude, you translate that height into forward velocity and travel hundreds of kilometers without a single wing beat. Researchers have modeled this. At cruise, you likely travel at 80 to 130 kilometers per hour over multi-day migrations, potentially 10 to 12,000 kilometers. Non-stop. You are not a local predator. You are a continental one. Now, about your head. Your skull alone is approximately 2.5 meters long, longer than most adult humans are tall. The crest extending from the back of your skull is a biomechanical stabilizer, a rudder in three-dimensional space, a structure that allows your enormous head to function as a precision instrument rather than an aerodynamic liability. Your beak is not a beak in the common sense. It is a weapon, a spear, an axe, a probing tool, depending on what you need it to be. And your eyes positioned for forward binocular vision see with a resolution and a depth perception that reduces the world below to a map of possibilities. Forget what you know about this place. Strip away the names, the history, the 7 million people moving through it like blood through capillaries. Strip away the meaning human beings have layered onto every corner and avenue and bridge. What remains? Canyon country. The skyscrapers of Manhattan are not buildings. Not to you. They are cliff faces. Irregular, vertical, sun-warmed on the south face and wind-scoured on the north. Between them, the streets are not roads. They are hunting corridors long, straight channels that funnel movement, concentrate prey, and create predictable wind patterns that make low-altitude flight not just possible but efficient. The Hudson River is not a landmark. It is a flyway. A broad, obstacle-free corridor of thermal gradient, where river air and city air collide and generate precisely the kind of lift you need for takeoff from water level. Central Park is not a park. It is a clearing in a canyon system, an open-sky island in a vertical maze, warm in summer, heavily trafficked by smaller animals, and surrounded on all sides by the kind of updrafts that make it a natural staging area. You notice the hawk. You note its thermal. You take it. The hawk does not return. This is the other thing about a city reframed as an ecosystem. It already has an aerial predator hierarchy. Peregrine falcons, nesting on bridge cables, nesting on skyscraper ledges, nesting on the very same cliff face architecture that drew you here. They are fast, precise. Brilliant hunters adapted over millions of years for urban environments. They weigh approximately 1 kilogram. You weigh approximately 200. The hierarchy is not negotiated. It is simply declared. You have been circling for 40 minutes. Not hunting yet. Mapping, cataloging, the slow, methodical aerial survey that is not instinct but something closer to strategy, a cognitive process that paleontologists have begun to suspect was significantly more sophisticated in large pterosaurs than previously assumed. You have noted the open paddocks. You have noted the predictable movement patterns of large mammals in enclosures they pace. They return to the same spots at the same times. Prey behavior that, in an open Cretaceous floodplain, would be interpreted as vulnerability. Here, it is interpreted the same way. Here is what most people misunderstand about how you hunt. You are not a dive bomber. You are not a hawk. You do not plummet from altitude and snatch prey at high velocity. That method requires a body plan built for impact absorption, rapid reacceleration, and aerial agility. Your body plan is built for something different. You are a terrestrial stalker who happens to fly between hunting grounds. On the ground, you move with a biomechanical efficiency that surprises everyone who models it. Your forelimbs, the same structures that anchor your wings, function as powerful front legs. You are quadrupedal. You move with the fluid, purposeful gait of something that belongs on the ground as much as the sky. You approach. The strike, when it comes, is not a bite. It is a thrust. A spear strike driven by neck musculature that generated forces paleontologists compare to a medium-caliber weapon discharge. The beak enters from above at a precise angle, and the physics are simple. Your skull weighs approximately 50 kilograms. Your neck muscles accelerate it. The kinetic energy transferred on impact is not survivable by anything your size or smaller. It is not violent in the way violence is usually understood. It is mechanical. It is over before the sound of wings has faded. You have not exerted yourself. That is the most unsettling part. You hear it before the pilot hears you. Low-frequency vibration. Rotor wash generating a pressure signature you have no name for it did not exist in any environment that shaped your instincts, but your nervous system does not need a name for it. It reads, rival. The news footage that survives this moment will be replayed more than any other clip in broadcast history. 47 seconds of stabilized high-definition video showing something that the human mind processes in layers, first as impossible, then as terrifying, then, somehow, as beautiful. You bank, not away from the helicopter, toward it, not aggressively, not in the way a territorial mammal charges, more like an atmospheric adjustment. You redirect your thermal ride to pass within 12 meters. The rotor wash hits you. This is the part that every aeronautical engineer who later studies the footage fixates on. At your wingspan, at your glide ratio, at your aerodynamic profile, the rotor turbulence that would flip a hang glider and destabilize a light aircraft does almost nothing to you. You correct with one slight adjustment of your wingtip. 1. The pilot files a wildlife strike report. The FAA does not have a classification code for this. They create one. Flight corridors over New York are redesigned within 72 hours. Not because you have attacked anything, because at your scale, in shared airspace, the term rival means something different than it does at ground level. The sky, suddenly, has a new apex. It happens in stages. First, the birds. Pigeons vanish from the upper ledges, first the exposed cornices and water towers that they have occupied for generations. They do not leave the city. They compress downward, retreating to lower floors, to alley level, to the protected microhabitats under bridges and elevated train tracks. The peregrine falcon's 12 documented nesting pairs across Manhattan alone stop using their traditional high-altitude hunting patterns entirely. They shift to ambush hunting in the lower urban canyons where your wingspan cannot follow. Adaptation, compression, survival by retreat. Then the hawks disappear from the thermals over Central Park. The park's aerial column, once a shared resource for every soaring bird in the 5 boroughs, becomes yours exclusively between the hours of 9 a.m. and 3 p.m., when thermal activity peaks. No bird challenges this. No bird is equipped to. This is what ecologists call a landscape of fear. The concept was developed not to describe direct predation, but the spatial distortion that an apex predator's presence creates across an entire ecosystem. Prey animals do not need to be killed to be controlled. They simply need to know with animal certainty that the predator exists, that it watches, that it can reach them anywhere they expose themselves above a certain altitude. Knowledge reshapes behavior. Behavior reshapes the landscape. The landscape changes without a single additional kill. You have not hunted in 5 days. You don't need to. The fear does the work for you. You cross their sky in 40 seconds. They watch. Not screaming, not running, just watching. As if they know, instinctively, that they are not the target. They are simply irrelevant, and that is a stranger feeling than fear. You open your throat, you wait, you call again. Silence. The sky answers with nothing. Not rejection, not hostility, nothing. The profound, absolute nothing of a signal sent into a space that contains no receiver. You are the last. Not last as in the last of a dying population facing extinction. Last in a more total sense. Last as in the only. The singular. The 65 million year gap between your kind and the present moment yawns beneath you like a second atmosphere. Invisible and bottomless. There is no one to challenge your territory. There is no one to share it. The sky that you have claimed all of it, every thermal column over every burrow, every corridor above every river, every altitude band from the rooftops to the cloud base is perfectly, completely yours. And empty. You watch this. You have no concept of beauty, no aesthetic faculty that maps onto the human experience of standing at a window and watching a city come alive at dusk. But you have something. You have the calibration of an organism that has evolved to read environments, to assess territory, to identify resources, to recognize pattern and anomaly. And what you are reading right now, from 800 meters above sea level, is a pattern of extraordinary complexity, generating heat and light and movement in a way that nothing in your evolutionary history prepared you to interpret. The city is alive in a way you cannot categorize, and it does not need you. This is the thing about absolute dominance. You have won the sky. Every cubic meter of atmosphere above this island is yours without contest. No rival exists to challenge it. No other creature in this world can occupy the same ecological role. You have achieved, by every biological metric available, total success. The species below you, the ones filling those lit windows, moving through those gridded streets, the ones who pointed and photographed and filed reports with aviation authorities, they do not look up at you as prey. They look up at you as witnesses. And here is what neither of you will ever quite articulate. They built upward because the sky called to them. They built towers to touch altitude they were never designed to reach. They built machines to carry them into the airspace that their biology denied them. They looked up for millions of years before they could go there. You were always there. You never had to want it. What you and they share in this moment, across 65 million years of divergent history, across the impossible gulf between extinct and contemporary, between ruled and ruling, is this. The sky is magnificent, and it does not care who owns it. You fly, because you were built to, because nothing can stop you, because the sky is yours, and you are alone in it. Quetzalcoatlus northropi was first described in 1975 by Douglas Lawson, based on partial wing bones recovered from the Javelina Formation in Big Bend National Park, Texas. The formation dates to approximately 66 million years ago, the very end of the Cretaceous period. The wingspan estimate of 10-11 meters is based on scaling from the best preserved specimens, though the largest individual is known only from fragmentary material. Smaller related species, including Quetzalcoatlus sp, are known from more complete skeletons. The giraffe scale standing height is supported by skeletal reconstruction. The forelimb-based quadrupedal launch mechanism rather than a leap is supported by biomechanical modeling published in peer-reviewed literature, primarily by researchers including Michael Habib. Weight estimates vary dramatically. 70 kilograms estimates rely on hollow bone scaling models. 250 kilograms estimates apply more conservative density assumptions. The true weight likely lies somewhere in this range, and the debate is scientifically active. The soaring flight model using thermals for long-distance, low-energy travel is supported by aerodynamic analysis and is broadly accepted. Estimated flight speeds of 80–130 kilometers per hour are derived from these models. The terrestrial stalking hypothesis that Quetzalcoatlus was primarily a ground predator using its beak to probe and strike at prey, rather than a plunge diver, is supported by skull morphology and neck biomechanics. It is the current scientific consensus, though not unanimous. Cognitive capacity and hunting strategy are inferred from structural analogs in modern large birds and from neural endocast estimates. We do not have direct evidence of Quetzalcoatlus' behavior. The landscape of fear dynamics depicted in this script are real ecological phenomena documented in wolves, large sharks, and raptors, and are plausibly applicable to any apex predator, including large pterosaurs. Their application to Quetzalcoatlus specifically is speculative. The mating call depicted is entirely hypothetical. Pterosaur vocalization is unknown. Some researchers have proposed they were capable of complex sound production based on skull structure. This remains unconfirmed. The urban environment scenario is a thought experiment. Quetzalcoatlus is not alive. It did not coexist with modern humans, cities, or aircraft. The thermal adaptation to urban environments, while plausible given how modern large birds utilize city thermals, is a logical extrapolation, not documented behavior. The emotional and philosophical dimensions of this script are, of course, entirely human projections. Quetzalcoatlus had no existential experience of solitude. Or if it did, we have no way of knowing. If you made it this far, you already know what this channel is about. We go further than the textbook. We go all the way to the edge of what we know, and then we stand there and we look out. Subscribe if that's where you want to be. And if you want to go deeper on Quetzalcoatlus, the real science, the active debates, the researchers still working on pterosaur flight mechanics right now, the links are in the description. The sky has always belonged to something. Learn what?